In this video, we'll be determining the domain and range of a quadratic function in factored form. So in factored form, the more general form would be y equals a outside of x minus s times x minus r, where r and s represent some values of the x-intercepts. So when I'm looking at this function, what is important to me is which way is this opening, and what are the coordinates of the vertex. Well, if I want to find which way it's opening, the first thing I would look at is what would be an a value. So the a value in front of this, even if I multiplied it out, so if I look at multiplying just a bit of this out, my leading coefficient is going to be 1x squared. Now that's enough for me to determine which way this function is going to open. If I were to multiply it all out using FOIL, I get x squared minus 8x plus 12. But the main point here is that the a value is greater than 0. So I know the function is opening up. Next, if I want to find the coordinates of the vertex, it's important to remember some characteristics of the quadratic function. The quadratic function in general is symmetrical. So if I know 2 points or 2 intercepts, then those intercepts are the same height, which means they're also the same distance away from the vertex. So what I can do when I have 2 of these, then I know that I've got one intercept here at 2 and 0, and I've got another intercept here at 6 and 0. So if I want to find the vertex, I can add my 2 intercepts and divide by 2. So that gives me 8 over 2, which equals 4. And as in previous examples, if I want the y coordinate of the vertex, I can replace the x value in the factored form. So I've got 4 minus 2, 4 minus 6. That will give me a value of 2 times negative 2, so negative 4. Meaning that the coordinates of my vertex are located at 4 and negative 4. So when I want to write the domain and range, the domain for this function, because again, once again it's quadratic, x is real. If I want to write the range, again, because this is opening up, vertex is a minimum point, meaning all other y values have to be equal to or larger than that point. And we found that point to be negative 4, while y is once again a real value.